this week's NFV SDN Reality Check, we'll look at some of the top news stories of the week, as well as speak with Coriant about the benefits of SDN deployments for mobile operators.
Today's episode is brought to you by Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.net.
Thanks for joining us on this week's NFV SDN Reality Check. I'm your host, Dan Meyer, Editor-in-Chief at RCR Wireless News. We'll start with some of the news of the week in the world of NFV and SDN. Overture this week said it recently conducted further trials of a multi-vendor service chain of virtual network functions running on common off-the-shelf servers, again showing line rate throughputs of up to 1 gigabit per second, with claims of low latency and low jitter. The company said the tests were conducted and validated by the European Advanced Networking Test Center, and again showed pure-play NFV can provide carrier-grade performance without the need for proprietary hardware or software. Partners in the latest testing included Brocade, Fortinet, Spirent, Ixia, and Supermicro. You can check out a conversation I had with Overture on the initial testing results in episode 14 of the NFV SDN Reality Check on the rcrwireless.com site. On the topic of service training, Alcatel-Lucent's New Age Networks division said it recently completed an evaluation and testing program with Telefonica Business Solutions that included service training of VNFs in a multi-vendor SDN environment. The proof of concept used New Age Networks' virtualized service platform working with an Alcatel-Lucent service router and virtualized service router. The companies claimed the demo showed seamless integration with Telefonica's existing third-party IP edge routing platform and the roles of data center gateway and data center provider edge. As always, a lot of news happening in the NFV and SDN space. Well, I recently had a chance to speak with Bill Kaufmann, who's the group manager of SDN planning at Coriant, about what the vendor sees as some of the benefits of SDN implementations for mobile carriers. Let's take a look at the interview now. All right, well, we're joined today by Bill Kaufmann, who's the group manager of SDN planning at Coriant, to talk a bit about the SDN and NFV space. Hey, Bill, thanks for joining us today. We appreciate it. Great. Well, maybe start off with, I guess, can you give us a little overview of the company itself, maybe for those who don't know much about Coriant, what you guys do, how you guys kind of participate in the telecom space?
All right. Well, Coriant's been around for about 35 years in different formats. So we actually are a combination of some parts of Telabs company that many of you may know. We have a kind of a long-haul division that was originally part of Nokia Siemens, and we also acquired some part of Sycamore Networks. And so it's really a combination of some different companies that have been around for a long time, and we kind of rebranded into Coriant about 2 years ago. We kind of focus on the IP/MPLS router market, as well as packet optical transmission equipment, both in the metro and the long haul. And so really kind of an end-to-end solution there with a service provider focus, although we do work with some large enterprises, government agencies, things like that as well. And and we're maybe like 90% of the kind of the top 100 carriers these days. So we have pretty good coverage with our products and, a number of, all around the world, really.
Sure, that sounds good. Well, obviously, you guys have probably a lot of insight on what's happening out there in the market, and obviously, on this program here, we cover a lot of the SDN and NFV stuff. And so maybe from you, some insight on what you're seeing out there in terms of how the market is, progressing in terms of its support for telecom operators, specifically more the mobile operators, as they move towards these virtualized platforms. I'm sure you're seeing quite a bit there. What are you seeing, in the market right now?
Yeah, so it's interesting. I mean, there's sort of two sides of what's going on right now. One is the NFV side, as you said, the virtualization space, and the other side of it is the SDN, and sometimes they're kind of lumped together in the same because they're very much related. But it's interesting regarding mobility in particular. We actually commissioned a survey in conjunction with Heavy Reading last year, where we surveyed carriers on how they felt about these things. And on the one hand, we saw a lot of interest in POCs and trials of SDN this year, next year, and even in the last couple of years. Virtualization, though, NFV has been a little farther out for them, and kind of and we see that also in our interactions with carriers. And one of the kind of views we have of that is that if you compare this kind of to the data center space as well, in the data center, virtualization is huge. SDN is very prominent. But if you have that virtual server and you have that virtual storage, in order to offer that as a service, you have to connect them together with some kind of network and then connect your user to that kind of combined virtual entity. Same thing happens in the in the mobility space, for example. where you want to offer a service, a virtualized service, but the network itself has to be programmable in some way to enable sort of this automated connectivity based on a very dynamic application environment. And so in some ways, the SDN becomes a precursor to the NFV, and if that makes sense.
Yep.
So, and so we see a lot of interest, for example, in virtualization, virtual EPC, but that in some ways contingent upon a network that can handle a new dynamic kind of, way of operating.
Yeah, it's a great explanation, because I know, like on this show a lot, I do kind of lump them together, SDN and NFV, but you're right, they are kind of almost two different platforms, really. I mean, it does seem like NFV is somewhat reliant perhaps on SDN to have some sort of control there, but there is, it's kind of separate routes for those. I mean, it did seem like initially, from the people I was talking to on this topic, that SDN was kind of out there ahead of time, or kind of maybe a little more progressing, a little quicker than perhaps NFV was. But then it seemed like earlier this year, NFV seemed to be getting a lot of traction. But now it sounds like what you're saying too, SDN has still got some pretty good, I guess, lead there in terms of how operators are moving towards these technologies.
Yeah, I think so. That's certainly what we see. Yeah. And, and once again, going back to mobility, which is a little different than other parts of the network, and, in your basic IP network, any node can connect to any other node. But when you come to mobility, you have to rely on GTP tunnels. Traffic is tunneled back to some kind of anchor point. At one point that was a BSC and 2G, then it was an RNC and a GGSN, and now it's going back to the EPC. But in any case, you're always kind of tunneling your traffic back to some central point, which limits the flexibility in some ways. At that central point, you do have your S gateway and your P gateway, and then the GI LAN interface is what goes from that P gateway to the public network. And it's really there where you can do some interesting service chaining and such from an NFV standpoint. But if you really want to break that apart and make it more flexible, the idea is, to try to take that packet core itself and virtualize your S gateway and your P gateway and these sorts of things, and really break apart the forwarding plane of the traffic from the control plane. So you still probably want to go to a central repository for your user profiles and your subscription information and all that. But really breaking apart that forwarding plane, can really make a very dynamic network. That's where, at least in my mind, a lot of the real, the real the benefits of virtualization come about in a mobility play. Yeah. But you have to have, once again, a very flexible network to accommodate this new environment. And so that's, once again, where you see those two pieces coming together.
Got it. Makes sense. I guess as you're talking to the operators and working with carriers out there, how far along do you see them in this process? Because obviously it does seem like it seems like we're kind of still early in the process. I mean, I've talked to some carriers, and some are a little more advanced than perhaps others are. But it does seem like, again, a lot of these POCs going on still. Some operators are kind of dipping their toe in the water a little bit here and there. What's your general view on how far along the operators are in actually adopting some of these platforms in their actual networks?
Yeah, well, you see here and there, you see some move forward. I mean, there's a company that's often referenced to PACnet out in the APAC region. Yep. They have a lot of data centers, a lot of sort of global presence in APAC, and they developed kind of an SDN solution. Actually, were acquired by Telstra out of Australia. But so there's one example of something that's in the network today. But I think you're right, Dan, that in general the carriers are doing lots of proof of concepts, lots of trials, seeing how this is going to work. But I think we have seen a change over the last 12 months where it's not enough to just do POCs and demos anymore. They really want to start considering, how am I going to operationalize this? I have a massive, back office system that exists today. How do I integrate this new SDN-defined service into that? It's great that I can define a new service in a new flexible way with maybe a user portal of some sort. Mm-hmm. But what happens when there's a problem? How do I troubleshoot that? What happens to alarms? How does that integrate into the kind of the management and the network operations piece of how I run my company, which is very important for the service providers. So it's that level now that we're sort of digging down into, is really the details of how I can roll this out. And then I think we'll see in the big providers, some move forward to actually deliver new services pretty soon.
Yeah, I think you make a good point there. I know I've talked to a lot of companies about this, and that's kind of been one of the, I guess, maybe the barriers or one of the challenges, it seems like, is, this is such a big move for operators to move kind of companies that are so historically based on hardware to move towards a software environment. And you get all these people who already work in these companies who have this history in hardware and now have to start working more with software. There's always this concern about, when you first roll it out, when you get that first alarm, on a Saturday night at 2 or midnight or something like that, and something's going wrong with the network, and the network guy's freaking out, like, what do I do? Who do I talk to? Who do I call? And so there's always like kind of like this nightmare scenario, like, we're going to roll this thing out, and the first weekend we're going to have this huge issue, and what do we do? And so that does seem like that's kind of maybe one of those challenges. I'm sure we'll talk a bit more of the challenges later, but you bring up a point that I've heard a lot from people, is the fact that that's kind of a bit of a concern for I guess advancing this rollout of these services.
Yeah. When you talk about automation and programming and these different things, and exposing just the service layer to an application to make service requests, and then this controller takes care of all of the actual network configuration. You start to move into an area where you have to rely on that system to do what it's supposed to do. And if you're looking at some sort of optimizing traffic based on latency or congestion or different things through a centralized control plane, you have to trust that system's going to work, and that trust comes from lots of trials, lots of and into gradually rolling out services step by step. And so you're right that it's the network managers are they're very hesitant to roll these out because it's all new, but you can certainly see that there is a huge dynamic that can be taken advantage of once they take that step, and once the systems are in place and they're stable and people are comfortable with where things are moving.
Yeah, got it. Makes sense. I guess, how important is it for operators to make this step towards virtualization? I mean, it does seem like, historically networks have run fairly stable. I mean, obviously there's service level issues every once in a while, but for the most part, telecom networks are seen as fairly reliable considering the amount of traffic that they handle. How important is it going forward for these guys to move towards virtualization and kind of move away from that legacy mindset to this new world? And obviously there's challenges involved in that, but how important is that for the operators to do it, and for the I guess industry to move that way too?
Yeah, and really it's you have two different mentalities here, right? Within the service provider industry, it's not just that the systems are reliable by chance, but they're reliable because they're made to be very reliable.
Yeah.
There's lots of resiliency put into place. We have very dispersed networks, and you have dual routes and resilient nodes and all these things. You flip around to a application environment in a big data center, and you have racks and racks of servers. And if a server goes down, well, there's another server right next to it that can take over the load, and I think there's much more tolerance to faults in that kind of environment. But you can't, if you have a router sitting there in the middle of the network and it goes down, there's no router sitting next to it that it can take over necessarily. So it's a different environment you're working in.
Yeah, I mean, obviously it does seem like but you're right there, because it does seem like the data center environment is a much different one. And I guess it just seems like that these carriers need to kind of, I guess, embrace that new medium. Because again, it does seem like that the data centers have proven these models that they do work. It's just a matter of getting the telecom guys on board to say, okay, I guess we can do that. Obviously, it'll be challenges in the fact that they do have this legacy equipment out there as well that they're going to have to support for a long time, and there'll be orchestration issues going on, I'm sure, as well too. But I'm guessing that the industry itself and the vendors out there are working hard on making sure that stuff is all put in place as well. Yeah,
and you can also look at some examples of some of the over the top providers, right? Like Google. So Google builds massive data centers. Facebook built massive data centers, and that's where their different services are kind of based out of. They also realize it's not enough to just have a big data center, right? So they go out and they have Google's global cache. They have these caching appliances they've designed. Netflix has their OCA kind of appliance they use for this thing. They put them on site at carrier locations because they know that it's not enough to just have one big location where you source all your data. And so that's kind of, that whole caching is in one way a move towards virtualization of content delivery. And so it's not that they necessarily want to move in that direction, but they have to do that in order to give their end users the best quality of service. Likewise, carriers are building their own content delivery networks, and that sort of is in some ways the first step towards acknowledging that we can't just backhaul everything to one location and pass it off to the internet. We need to start distributing intelligence around our network. So now you look forward to 5G and mobile edge computing and these new concepts. And NFV really becomes part of where the future design is being oriented. And so these concepts of virtualization are going to be embedded in some of the new generations of mobile technology, very likely. And so it's almost a question not of whether or not we want to move in that direction, but in order to go the next step and deliver this content and be efficient, we have to move there.
Yeah, that's a great point. You're right. It does seem like that all the talk around 5G, which is still very early stages, but a core part of 5G seems to be this move towards virtualization, towards automation, to having these networks being able to almost run themselves for the most part. Because again, it does seem like the increased amount of traffic that people are expecting on the network, data traffic, voice traffic, everything that's coming on the network now, it's almost like the humans we can't we can't keep up with it for the most part. And we almost have to have the computers that are able to handle this, and obviously you need more processing power, and that seems to be happening pretty rapidly. I know the x86 architecture for this is a big part of this, but it does seem like that is kind of what's needed. Is you almost have to, like you said, you have to kind of be on board with virtualization in order to support what's coming next, whether it's 5G or whatever you want to call it. But to be part of that, you need to have at least this layer there, and eventually it'll become a bigger part of the network as well going forward. Yeah,
that's exactly right, Dan. And once again, you go back to the data center world. There's no way you could scale the data center without taking your foot off the pedal a little bit and letting the network actually automatically create these virtual network connections.
Yeah.
So it's a direction we're moving, whether we want to or not. And it's a question of how do we accommodate that, and really if you get back to that idea in the mobile world of this GTP tunneling and anchoring all that traffic back into the core, as traffic loads increased, you really want to have to pull all your traffic back to one single handoff point or a small number of handoff points, as opposed to dumping that traffic off sooner in the metro area to internet peering points or caching servers or whatever, and that once again leads you to saying, well, I need to start pushing intelligence farther out to the edge of the network. A great data point that I recently saw was, I think, around 6% of handsets are now 4G enabled kind of globally. You're still kind of getting up to speed on 4G and LTE. But those 6% of handsets take up right now about 40% of all bandwidth. So you can just tell where the bandwidth growth is going to lead us.
Yeah.
And at some point, you're going to have to acknowledge that it does not make sense to backhaul all the traffic into the core and then hand it off. You want to have a more diverse network environment, take better advantage of that network you have, not swamp your backhaul trunks with unneeded connectivity. And once again, that leads you down the path of whether we want to or not, we need to start distributing and virtualizing our content.
Yeah, that makes sense, obviously. Now, again, with these different evolutions of different services, whether it's IoT even, I mean, you can, billions and billions of new devices coming out of the network, maybe not doing a lot of traffic, but they're going to be on the network, and, they're pretty small bandwidth, but you still, is it worth bringing all that stuff back to the core, or can you just distribute it out there and run it that way? I mean, there's just so many use cases, it seems like, where virtualization can be a big part of these new movements, whether it's services or technologies, a big part of what's going on out there.
Yeah, and that's a great point you bring up about IoT also. It's every time you bring up one of these things, the new things kind of spin through my mind. Sure, but so with IoT, another thing about IoT is that, the prediction at least is that we're going to have many more IoT devices out there than we currently have mobile devices today, which is great. It's, lots of new applications. But now you have to think, are you going to backhaul all that traffic to that same EPC, that same serving gateway, and the same MME that that controls your normal handset users? If so, even though the bandwidth might be very small per device, you still have a control plane load that you now have to maintain for all these new devices. And you could very easily overwhelm the control plane of your packet core, even though you're very much underutilizing the bandwidth capacity of that packet core device. So then you move back to virtual EPC. Can I break off an EPC and dedicate that to one particular IoT function, scale it down to support, a connected city, set of, 10,000 sensors around a metro environment, for example, and dedicate my EPC to that one application. Once you can virtualize it and once you can start to break apart the applications in this way, it makes that kind of thing possible and fits better the environment where everyone is not just a handset user or an iPad user or a tablet user on the network, but you have lots of different types of applications you're trying to integrate on the same network.
Yeah, and obviously I know I've talked to some carriers about this too, is that, their concern with the IoT models is, how do you get a business case for a lot of these? Because obviously a lot of these devices out there are going to be low bandwidth, very low usage, but you still need to somehow bill for them and be able to, have a service or a rate plan out there. And so it's like a scalability issue that it seems like virtualization really can play into, because it will allow operators to be a little more dynamic in their pricing models and their usage models and how they deploy services out there. I mean, it does seem like it allows them to really play more aggressively and probably more profitably in the IoT space. Because again, that is a market that people still aren't quite sure what the financial implications are of going this model. Obviously, there's a lot of devices out there, but how do you bill for them and things like that? So it does seem like virtualization could be a good way for these carriers to kind of, I guess, play a little more aggressively in that space too.
Yeah. There's a concept within SDN of network slicing, right? You create your network and in an IP world, you think, well, that's just an IP VPN, right? Or a VPLS instance. But if you look at the network as a whole and you want to slice that and kind of partition off a part of your infrastructure to be used by a particular application, now with a dedicated VPC to one application and some kind of SDN control of the backhaul network, you can actually provide almost a kind of a virtual dedicated backhaul network dedicated to one application, and that just opens up the carriers to sort of new service models, new business models of how they can utilize the assets they have, and monetize them in a new way that isn't really possible today.
Yeah, it makes sense. I guess as you look at kind of this move towards virtualization, I mean, are there parts of the network that basically that you see maybe can't be virtualized? I mean, I know I've talked to a lot of companies in the past, and some of the early guys were very aggressive and saying, "Hey, we can virtualize pretty much everything except the antenna at the base station." I guess as you look at the networks out there, I mean, how deep can virtualization using these technologies? How deep can we go with this? Do you see a limit? I mean, obviously there are different carriers, all different mindsets about this, but what's your view on kind of how far can we go with this move towards virtualization?
Well, I mean, eventually traffic at the edges is going to be, backhauled to some location.
Yeah.
Now you may push some content out to the edge through edge cache or something like that.
Sure.
But there's always going to be a logic to backhaul network to some location. So you're always going to have that piece of it there.
Mm-hmm.
You certainly can't virtualize the physical nature of the network. The microwave links, the optic fibers, the routers themselves, as opposed to a data center, once again, where you have racks and racks of servers and top of rack servers and massive connectivity, you have limits to connectivity in a backhaul network.
Mm-hmm.
You have to work around. So at some level, you have this physical infrastructure. It's never going to be quite as dynamic as a kind of a single site, data center world.
Sure.
And then that's going to cause, probably present some limitations. But within that, it's how can I take this thing and how can I make it as flexible as possible? And then once again, go to the application layer and say, hey, don't worry at the application layer, don't worry at the service management layer how this network is built. You tell me where you want to build your connection from point A to point B. I'll build that connection with a given SLA, and then as that application gets congested or gets utilized, we can then split traffic and load balance traffic to multiple locations, and we can create this sort of virtual world at the access layer. But as you say, fundamentally, you can't virtualize everything, and even with, I think there's some question, within the router itself.
Yeah.
Although in theory, the control plane can be virtualized and the packet forwarding can be virtualized. Some of the NPUs and ASICs and such that run in routers today are very specialized around IP packet processing.
Mm-hmm.
It's sort of a specialized function, and and that function may be something that you want to keep at a hardware level and not completely virtualize that. Although who knows how the future may end up.
Yeah, and I guess theoretically, what you could do is, obviously maybe not in the U.S. or in the Western Hemisphere, where it seems like most of the operators here like to control more of their network operations, but it seems like in some markets that are a little more open to network sharing, perhaps, you could have basically one physical network out there and have multiple operators, almost like an MVNO type of model, but you have multiple operators using virtualization in their own, in their little sector to kind of meter out how much of that network resources they want to use. You could have multiple operators sharing one big resource using software to kind of parse out what you need from the network, what you don't need from the network, figure out all the billing and stuff like that. But I guess theoretically, maybe that's a possibility. But again, in the U.S., for sure, most operators here like to have that kind of control of their network, so it doesn't make a lot of sense. But it seems like that's maybe possible. I don't know, just an idea out there. But I'm sure people are looking at that.
Yeah, and at a minimum, that MVNO model, right? That at a minimum, that's something. And once again, the IoT piece starts to create some flexibility there too. So there's lots of things. Eventually you have a network you have to deal with. There are physical links in that, and that's just part and parcel of what a backhaul network is. But there's certainly a lot new that can come out of that.
Yeah, obviously cell towers and fiber are not going to go away. You need to have those things out there at some point. So you got to dig a hole and put up a tower. So that's going to happen.
Yeah.
Very good. Very well. I guess as you looking ahead, what do you see perhaps some of the bigger challenges going forward when it comes to, I guess, continue moving towards SDN and NFV, at least in the mobile space? What do you see as maybe the one or two bigger challenges over perhaps the next 6 to 12 months or so as we kind of continue this evolution for networks?
Well, certainly how to take the step beyond a solution that can work and create services and create compelling services, taking the step to take that new infrastructure, then integrate it with the network that exists today.
Yeah.
But the biggest challenge we hear from carriers is, hey, this demo, this POC, this trial, this looks pretty neat. We like the way this looks, but we've invested over the years $100 million in our back office system, and we can't walk away from that. We have thousands of network operators that have certain MOPs they follow to run this network. We can't walk away from that. So how do we integrate this in? And also, we can't just put in a whole new set of equipment to support an SDN-based network. We need to somehow utilize the equipment we have today and migrate that network towards something that's more flexible and taking advantage of the things you're talking about. And so I think it's really those questions of migrating networks, of integrating with the back office, and showing the individuals within the carriers there are new ways to do things, the training that's involved in that the carriers take care of. All of those pieces are really the next step towards bringing the technology forward.
Yeah, that orchestration part of it is going to be huge because you're right. I mean, it does seem like over the next, people are talking about virtualization. I know AT&T, for instance, has said they set certain milestones that they want to hit, but there's a several-year period there where there's going to be these dual networks kind of running, the legacy networks and these new networks, and you got to have that orchestration in between them to make sure it all works smoothly. And again, like you said, I mean, these operators have spent a lot of money on equipment over the past 30, 40 years that they're not just going to throw away tomorrow. So that will be a challenge to kind of make sure that everything's talking, working together and talking nicely. And obviously, standards are a big part of that too. I know standards is a whole different discussion there, but that's been ongoing and trying to work through, make sure everything's talking together and can talk the same language. That's going to be definitely a big part of what happens with this going forward for sure.
Yeah. There's that whole. It's a great point. There's this whole concept of these APIs, these programming software APIs that allow the different controllers to speak to each other and the orchestrators to speak to the controllers. And those APIs are at this point really not standardized. There are versions out there that people use, but there's no standardization. Even the data models they're based on are not fully standardized. And so there's a lot of work to do to get us there. So that also holds you back when it comes to multi-vendor networks, which just about everything is a multi-vendor network these days. But multi-vendor networks, how do you get your different competitors to agree on one sort of single way of working? How do you orchestrate between all of those? How do you get an end-to-end view of the network? And that certainly is going to be a challenge as well. Yeah,
I mean, does it seem like the vendor community is working towards that goal? I mean, does it seem like there's enough cooperation out there still between the vendors to kind of make sure that at the end of the day that their equipment can communicate with everybody else's equipment? Because again, I know operators ideally want to have that multi-vendor environment out there, but initial deployments are always kind of tricky because you get these certain vendors working in their own little silos and everything works great in their own little thing, and obviously you do POCs to make sure things maybe can kind of work together. But when you go to actually put it out there commercially, that's always a bit of a risk. Does it seem like the vendors are working towards that goal today?
Well, as a vendor, I will say yes. But to be honest, it's often in these kind of cases, it's often the carriers that drive you towards, sure. Coriant and 3 other companies, I've chosen you for my network. Now you've got to make it work, and here's how it's going to work. And if you want that business, then you follow their model, and and sometimes that kind of drives standards forwards also. So, but certainly there are lots of vendors involved. Different people have their own opinions. But that's the same for for 5G as well. The whole 3GPP and all the organizations involved there is a mix of vendors trying to get together. But I think we all fundamentally will see that once we agree on standards, it benefits everyone. So it's a question of but it takes time. It takes time.
Yeah, it's a question of when at this point. Obviously, a lot of smart people are working on this behind the scenes, and so again, that many people together, it will eventually work itself out. But it's just a matter of getting there at this point. So.
Yeah,
a lot of sense. Well, it sounds good. Well, hey, Bill, definitely appreciate the great insight on this today. Obviously, a very educational conversation. I appreciate it. You obviously gave me a lot of new acronyms to work with, which I always appreciate as well. But again, I definitely appreciate the time and the insight today on the topic. Thanks so much for joining us. We appreciate it.
Okay, thanks, Dan. I really appreciate the talk.
Sounds good. All right. And hey, thanks everyone for watching this week's NFV SDN Reality Check. And make sure to check us out again next week.
NFV SDN Reality Check with Dan Meyer is a production of RCR TV. To suggest show topics or to reach Dan, you can find him on email, dmeyer@rcrwireless.com, and on Twitter @Meyer_Dan. For more Dan, news on NFV SDN and everything wireless, find your way over to rcrwireless.com.